So this video is about calculations, and the main reason I'm doing this is because I want to remind you about setting out your working. This is really important. It's really important that when you're doing calculations that you set your working out neatly so that you can keep track of what you're doing. This is one of the biggest areas where I think people go wrong with calculations and get themselves mixed up. So, first thing to remind you about calculations is that you don't need to memorise any formulas in chemistry. Your formulas are in your data book. Main ones that I'm going to go through today are N equals CV and N equals M over GFM. There is no excuse for getting these formulas wrong because you have to use your data book and they're there. So make sure that whenever you see a calculation that you do use your data book to get the formulas. Another page of the data book which is important is the table of relative atomic masses. Whenever you need to use the GFM, the gram formula mass in a question, you'll need to go to this page, page 7 of the Nat 5 data book, or it'll be a different page in the higher data book, and we'll get there when we get there. So, first example, calculate the formula mass of water. So I'm going to do an example about formula mass as an example about gram formula mass, just to remind you about the difference between the two. So, formula mass for water. The formula for water, we all know, is H2O. To calculate the formula masses, you'll need to use the relative atomic masses, as I mentioned on page 7 of the data book. Relative atomic mass of oxygen is 16. Relative atomic mass of hydrogen is 1. Now, in the formula there is 1 oxygen and 2 hydrogens, so you need to add the total of the relative atomic mass of all of the atoms in the formula. So that's 16 plus 2 is 18. Now, this has just said formula mass, it hasn't said gram formula mass. Because the units are just the units of relative atomic mass, I'm going to give this units of atomic mass units, or AMU. So that's your way of laying out your working for calculating the gram formula mass. This is important. It's easy to make mistakes with these, so please make sure you're laying out some form of working, preferably like I'm doing here. Example 2. Calculate the formula mass of C3H6, so that's propane. Sorry, and that was the gram formula mass. So pretty simple, C3H6, again we need to use the relative atomic masses of each atom on page 7 of the data book. Hydrogen is 1, there's 6 of them, 1 times 6 is 6. Carbon has a relative atomic mass of 12, there's 3 of them, 12 times 3 is 36. 6 plus 36 is 42. Now the gram formula mass is the number of grams in 1 mole of a substance. So I'm going to give the gram formula mass the units of grams per mole. And using these units for gram formula mass will help you to make sense of the units when you actually come to use this quantity in an equation. Okay, example 3. Calculate the number of moles in 5.6 grams of CO2. So, first of all, when we're given a calculation like this, we need to work out what number, what equation that we're going to use. To do that, I would underline the key information that you're given in the question and try and figure out what you're asked to find. So you're asked to find the number of moles. Remember, the symbol for number of moles in chemistry is N. The information that you're given is that you have 5.6 grams of CO2. Remember that 5.6 grams tells us that that is a mass of CO2. Once you've worked out what you're trying to find and the information that you're given, you then need to work out which equation to use. When you have moles and mass, that should straight away tell you that you're going to need to use N equals M over GFM. And always double check that in the first page of the data book that you've got that equation right. So to help us calculate N, which is the number of moles, when we're given the mass, we also need to calculate the GFM of CO2. Now I'm going to lay out my working for that separate to this data column here, which I've written out. So my GFM for CO2 is 44 grams per mole. So notice that when I'm writing out this data column, I've got the three terms that I'm using in my equation all laid out in a line, and then I've got the quantities filled in, as well as a question mark for the quantity that I'm looking for. Also notice that I'm putting in the units of my quantities beside them. That's really, really important, because particularly at higher, you'll start to get calculations where you're given quantities with different units, and you really need to keep track of your units so that you get your final answer correct. So now we've got to do the sum using the equation to calculate the number of moles. Because the equation is already set out to calculate n, I don't need to rearrange this equation, but I am going to make sure that I've written the equation out in full before I substitute in my numbers. So n equals m over GFM, which equals 5.6 divided by 44. Okay, so you'll notice that when I do this, I get a really long number on my calculator. What I would really like you to do when you're doing calculations in chemistry is to initially write out at least 5 or 6 decimal places of that number that you're getting in your calculator. So this is 0.12727, and it goes on like that. Write out 5 or 6 decimal places initially, and then do your final rounding. And I would round in general to 2 decimal places. Okay, so that's how I'd like you to lay out your working. I'd like your data column here. I'd like your full working for your gram formula mass, and I'd also like you to write out first the equation using the symbols, then substituting in your values, laying out your answer with at least 5 or 6 decimal places, and then finally rounding your answer if needed. Okay, example 4. Calculate the concentration of 0.1 moles of hydrochloric acid, HCl, in 500 centimetres cubed of water. So again, we're told a number of moles, so this time we've got a value for n, 0.1 mole. And we're also given a number in centimetres cubed, so you should know that centimetres cubed is a measure of volume, so 500 centimetres cubed. When you see moles in volume or moles in concentration, you know you're going to need to use this equation, n equals CV. Now that we've figured out what equation to use, we can fill in the symbol for what we're trying to find out. One thing to remember about this equation is that concentration is always going to be measured in moles per litre. So to work out the concentration, we need to have the volume in litres. To do that, we divide the volume in centimetres cubed or millilitres by 1,000, and that will give us 0.5 litres. So again, this time we need to rearrange this equation here. I'm hoping and I'm assuming that you're all comfortable with rearranging equations. If you're not, please let me know and I'll try and point you in the direction of some videos or something that you can use to help you. So n equals CV. We need to get C on its own, so C equals n over V. One good way to work this out, to double check that you're doing this right, is to put in your units. So we know that n is in moles and volume is in litres, and the units of concentration should be moles per litre, moles divided by litres. So that's a little check that we've got this equation the right way around. Concentration is number of moles over volume, which is 0.1 divided by 0.5. Which is 0.2 moles per litre. And because that's come out as a nice whole number, only 1 decimal place, I don't need to round that any further.